High, and today we're going to talk about another type of application problem that could come up, and that's determining whether 3 points are collinear, which means on a straight line. And so what we're going to do is we're going to deal with distances again. So just like we did in the example with the right triangle, and determining whether the points were vertices of a right triangle, we're going to do the same thing here with the distances. Okay? And so if we take these points, we're going to do the same thing. We're going to figure out what the distances are between these 2 points. Okay? And so the idea is if they are collinear, right? So if they are collinear, let's take this example, and we take P, Q, and R. Let's say we have that. If these 3 points are collinear, then we should be able to take this distance plus this distance should equal this distance. Right? So this is a little different than the one with the Pythagorean theorem. Okay? So, because it makes sense that if they're collinear, I should be able to take distance PQ plus distance QR, and that should equal the distance PR or RP. Okay, so that's what we're going to do. Okay, so again, we're not using the Pythagorean theorem in this case. We're just using the distances. We're not using the square of the distances. It's just the distances. Okay, so let's do that and see what happens here. Okay, so again, I'm going to set up my distances, and let's see if we can get this to work out. So this is -1. Oh, let me do this. PQ. Let's do distance PQ, and we're going to do distance QR, and we're going to do distance PR. Okay? Okay, so the distance from P to Q, again, we're going to use the distance formula to help us with this. So in this case, it's going to be these two. So we're going to do -4 minus, -4, or excuse me, 2 minus a -1. 2 minus a -1. Again, it doesn't matter if we do the y's first or the x's, but I just have to do the x's first. So 2 minus a -1 squared plus -4 minus 5 squared. And again, this is going to give us what? 2 minus a -1 is 3, so this is going to give us 3 squared. And then -4 minus 5 is going to give us a -9 squared. So we're going to get a plus 81. And so, let me do this way. Yeah. I don't think I'll run out of room, but just want to make sure. So this is going to give us 3 squared plus -9 squared, right? And so this is going to give us 9, and this is going to give us 81. And so that will give us what? Well, add these together, we get the square root of 90. Okay? Now, let's simplify this. So this is going to give us this is going to give us the square root, because we can simplify this even further. And so I'm going to write this just for a scratch work. Okay, so notice this is equal to the square root of 9 times the square root of 10. So this is 3, right? So this becomes 3. So we can write this as 3 times the square root of 10. Okay, so let's rewrite 90 as 3 times the square root of 10. Okay, so we got that one. Now let's look at QR. Okay, so now we're going to do the distance between these two. So we're going to do 4 minus 2. So square root 4 minus 2 squared plus negative 10 minus a negative 4 squared. And so this is going to give us 2 squared. And this here is going to be, negative 10 minus a negative 4, which is going to give us negative 10 plus 4, which is going to give us a negative 6 squared. And so this is going to give us 4 plus 36, right? 2 squared is 4, negative 36 squared is, negative 6 squared is going to give us 36. And this is going to give us the square root of 40. Which is going to give us what? This is going to give us, if we split it up again, this is the square root of 4 times the square root of 10, right? So the square root of 4 is 2, so we can write this as 2 times the square root of 10, right? Okay. So now, let's do the last one. So PR, so that's going to be these two. So we're going to do 4 minus a negative 1. So we're going to do square root 4 minus a negative 1 squared plus, and then we're going to do negative 10 minus 5 quantity squared. And now this is going to give us what? This is 5 minus a negative 1, or 4 minus a negative 1, which is going to give us 5 squared, right? And then we got negative 10 minus 5, which is going to give us a negative 15 squared, which is 225. Okay, so this will give us 25. This will give us 225. So this is going to be the square root of 25 plus 225, and which is going to give us the square root of 250. Now, again, notice that this can be rewritten as the square root of 25 times the square root of 10, and the square root of 25 is 5. So we can write this as 5 times the square root of 10. Now we've got it simplified, and so all we have to do is ask ourselves, can I take a combination of adding 2 of those numbers to get the third one? So obviously we look at the biggest number. Well, this is the biggest number, right, because all of these have a square root of 10, so this has the largest number in front of it, so this is the bigger number. So do these two add up to that? Well, remember our properties of adding square roots. So 3 times the square root of 10 plus 2 times the square root of 10. We can factor out the square root of 10 and treat this as 2 plus 3. And so yes, this does equal. So yes, these 3 points are collinear because it works. I can add these two distances, right? So I can add these two distances and I get this distance, therefore they're collinear. Okay? That's it. Have a good day.